Okay, so I wrote a little bit of a blog about it, and I'm going just to read it for you. Of course, I'm not going to do that.
Can you command plus?
No, I'm not going to actually read it. So it's just
Okay.
pointing out to it. So you guys, if you want to read the details of what I'm going to talk about today, not really the details, but sort of the highlights of what I'm going to talk about. But in order to demonstrate what I wanted to talk about here today, I created a little bit of a demo, and I'm about to share on GitHub here, following the principle of shut up and show me the code. So this is it. So this is a contract-first API development. It's an acronym from it, and it's a little app that you can run locally by running yarn and yarn dev. So essentially, let's say you are tasked with building an API for a client and a server. And here I mean a client and a server in a narrow sense of, or an API in a narrow sense of having a client that requests a data from a server. So that could be a website or a mobile app requesting a data from a backend, or it could be two services in a microservices architecture. So if you're tasked with that, how are you going to go about as a team to build the API for your client and server? You have a few options. First, you can have no contract at all. So your development team, your front-end development team, or your service one development team can start working on their code base, and your server team or your service two development team can start working separately and then communicate through meetings or markdown documentation, whatever. Another approach is to have your server team create their code base and then use some kind of tooling to generate some contract from the backend code base, and then share that with the front end, and have the front end follow that contract. Now, this is going to create some issues because you have to wait for the backend team to generate these sort of templates. If they're not going to write the entire thing, they will have to write those and then provide it to the as a contract, and then the front end can use it. So you can see that you cannot really parallelize the process in this sense. What I'm advocating here is starting out with the contract. And the contract here is simply a machine readable standard specification that you can enforce in both your server and your client. So in order to demonstrate this, I'm using OpenAPI specification here. And this is a very minimal specification file, so please excuse how contrived it is. And simply, let's say you're building an app that allows people to post machines they're using at the gym, and then see what other people are using by requesting all of those machines. So you have a couple of endpoints. And so here you have a health check and you have machines. And you start with this. So your front-end team and your back-end team sit down and just discuss this file and what kind of data they're expecting and what kind of data they send in queries and request bodies and whatnot. So for example, pagination would have this kind of parameters in it, an offset, and it's an integer limit, and it's an integer, and it's sent in query, and so on and so forth. So now, up to this point, there is no front-end code and there is no back-end code. So, or maybe there's just minimal, but really not the implementation of the API layer. So from this level, from this point, your backend team can actually use this contract. And here I'm going to demonstrate how they're going to use this contract to enforce these types that we just talked about. So I'm sorry that I'm going to use Nest.js here, but you can replace this by your favorite language, your favorite framework. I know a lot of people here love Django and Flask. I'm pretty sure there are some tooling around those frameworks as well, but I will use Nest.js is the one that I'm familiar with the most. Or you can use your own framework here, really. You don't need a framework for it. Oh, damn, that's short.
I'll give you another minute because we have technical issues.
Can you guys do 1 minute?
Yeah.
I'll rush through it. Okay, so
I want to see the end of this.
all right, so here we have the controller, and this is the machine's endpoint that we talked about earlier. And here you can see that list machine query validator. So what is this query validator? This is actually a generated interface or a generated class from our specifications. So you don't actually have to go by hand. Actually, this entire file is auto-generated. If you go to the top, this file is auto-generated. Do not modify this file manually. So this validator that which is list all yes, this validator is actually enforced by the framework, which is Nest.js in this case, and this validator class is created from our specification. So now we guarantee that if a client sends some rubbish data, the offset is not a number, or to Boolean or whatever, or some other data, we're just going to ignore it. How is the client going to benefit from this approach? Okay, so I'm going to go to the client now and see how it's going to request the data and how it's going to benefit from the contract. So this is a Next.js app, and I create an API agent file in which I simply I have to create an HTTP client, which a simple class that has the interface of get, post, delete, and whatnot. So simple the REST API methods. And I pass it the endpoint, and here I have all of my API endpoints as simple functions, async functions that I can simply run from my code. So in my component, in my React component, page in this case, I will simply, as you can see here, get my API agent and then call this list machines, which I defined in my Open API specs, and I will pass it the offset and the limit. And all of this is strong type. I'm using TypeScript in this case, so all of it is strong typed. So I can guarantee that and by the way, and it's also documented, so I'm going to stop now, and this is what contract-based API development is. Thank you very much.
I'm a fan of this type as well. At least it makes it easier than, hand-wavy contracts. Say, I'll add a new endpoint and it does this, and you find out that it doesn't actually do that. Usually it happens a lot in startups.
Exactly. And so for GraphQL, for example, you can follow another approach, which is code first. So you define your schema in your code, and then you have the schema generated from your code base. But that means
we do that in Python as well, right? So this is precisely what FastAPI does. You basically build your API endpoints, you annotate the parameters to the functions that basically views or endpoint, and it actually spits out Open API specification, right?
Including the validation, let's say you have an email field.
I do believe so.
Okay.
I'm not sure about complex validation or custom validation, but it definitely can do integers, strings, boolean. Yes, this one.
Oh, okay, I see. Well, yeah.
So this Open API spec is basically analogous to GraphQL schema, right?
It is analogous to GraphQL schema, yes.
Have you considered using GraphQL? Because I used OpenAPI before, and it's just way too verbose. I think it could accomplish that with the GraphQL schema. It does basically the same.
So true. So so choosing between GraphQL or Open or REST or gRPC, should be done based on the particular use of the project. So you're right. On all of my projects now, I use GraphQL because the tooling around it is much better. It's much more mature. However, you cannot say that GraphQL is always the right choice for every project, especially if you have a microservice architecture. So in that case, following this principle with any kind of transport style like GraphQL or gRPC should be fine, as long as you're following the principles.
Right. Yeah, you don't have to use GraphQL for the graph functionality, just for the schema part. You can treat it as just an RPC protocol.
And then use actual REST methods to interact with the API.
Yeah, basically, you can just create a bunch of methods in your query and a bunch of methods in your mutations and use it as an RPC kind of. It's not the intended use,
yeah.
But you used only the schema functionality, right? Because the libraries will validate all your parameters, etc. So you don't have to build a graph like it was intended to be used, but just an RPC kind of style.
Actually, yeah, I see some benefits to that because Open API, for example, does not support abstraction like creating reusable types. GraphQL supports that, so I guess in this case it would be a lot easier to use GraphQL. Instead, GraphQL schema.
I don't see any more, considering the versatility of GraphQL, I don't see any drawbacks of using it, even if you don't need the graph functionality. I just don't see why you would use just plain HTTP APIs anymore, considering how a Open API spec is verbose and you have to maintain it, and the tooling is subpar compared to GraphQL. And you can abuse GraphQL and just use it as RPC or whatever. You can, you don't have to use it as it was intended.
True. By saying HTTP, you mean REST APIs or?
Yeah, well,
Okay.
REST or just HTTP, as in just something
pure
over HTTP.
I see. Good.
Question.
Yes.
So yeah, from the discussion, I just want to clarify. Maybe is OpenAPI supports like non-HTTP protocol, like for example MQTT or maybe not the OpenAPI, but the contract-based concept itself. What do you think? If it's not using HTTP protocol, is it possible? I mean, why I ask that question is my company currently is working on AR, VR, XR stuff. So most of the time, you can consider the device as in terms of resource, it's limited, and also in terms of the power capacity. So mostly, maybe they need to use more lightweight protocols, less verbose protocols. Currently, I'm using MQTT. So yeah, I'm just curious whether this contract-based concept or maybe specifically using the OpenAPI is suitable to other kind of protocols instead of HTTP.
Well, I would say OpenAPI is only for HTTP and REST actually, so not only HTTP. So it's a higher level than that. But the concept is the same. So as Nick was saying, you can even use GraphQL as a REST schema, because it's simply just a PES. All methods are a post method in GraphQL. So you can do that, but then you would have to write all of your tooling because it's a very kind of custom or tailor-made use case. So you will have to do all of the heavy lifting yourself. So, but the principle is the same. Starting with the contract is going to save a lot of time if you have the situation that we talked about earlier.
Okay, so maybe the closest example would be like the stop in gRPC, I believe.
Stop?
Stop. Yeah, I think they have like stop function or something like.
You mean the protocol?
Yeah, in the
protocols?
I mean, you explained earlier that sometimes there is issues when integrating between the front end and back end because sometimes either the back end works first and the front end needs to wait, or the other way around.
Yeah.
So I believe there is something called stop in gRPC, so you can generate like an empty function. You can export into a library which can be imported to the other side of the. I mean, if you're creating the API in the server, you can load it on the client or vice versa.
Well, I think this is a side effect of having a contract because now you can. Well, I think what you're referring to is mocking.
Sure.
Mocking a server.
I just heard. I just remembered the concept. I don't remember.
Oh yeah, so stopping is kind of well, stops and mocks are different, but it's so yeah, having your calls going somewhere and not failing essentially. So your client can be developed without waiting for the server. But as I said, when you have the contract, you have that option, not the other way around. Thank you. I think we went over the 10 minutes limit, so thank you very much, and we're going to move on to our next speaker.
Brilliant. I'll probably want to come back to that during the discussion because I would like to know more about how you actually generate that